Hello, Assalamualaikum. My name is Akil. Number metric is 01DE24F1121. Today I want to present diodes in electric circuit. Definition of diodes. Diodes are semiconductor device that allow current to flow in one direction while blocking it in the opposite direction. Composed mainly of material like silicon or germanium, they serve as crucial components in various electronic devices, enabling functionality such as rectification, signal modulation, and power regulation. Function in circuit. In electrical circuit, diodes perform several key functions. They are primarily used to rectification, converting alternating current AC to direct current DC. Diodes can also protect circuit from reverse polarity, serve as voltage clamp, and function as mix and demodulation component in radio frequency application. Their reliable switching capabilities make them essential for various circuit design. Types of diodes. There are various types of diodes, each designed for specific application. Common types include: firstly, standard diodes. They are used for basic rectification tasks. Second, Zener diodes, designed to allow current to flow in the reverse direction when a specific reverse voltage is reached, commonly used for voltage regulation. Third, light emitting diodes, LED, emit light when current flows through them, widely used in display and indicator lights. Fourth, photodiodes, it convert light into electrical current used in optical application. Second, we want to present about rectifier function. Half-wave rectifier principle. We look I equals to current, D equals to diode, RL equals to load resistor, T equals to transformer. Positive is positive half cycle, negative is negative half cycle. We want to a half-wave rectifier allows current to pass only during the one half of the cycle, the AC cycle, effectively blocking the other half when the AC voltage is positive. The diodes conduct allowing current to flow into the load. Conversely, during the negative half of the cycle, the diode is reverse biased and does not conduct, leading to a pulsating DC output. The waveform generated include the original AC signal and the resultant pulsating DC, which can be smoothed further with filtering component. We look at a full wave rectifier principle. A full wave rectifier enable current to flow during both half of the AC signal, resulting in a smoother DC outputs. This can be achieved using either a center tap transformer with two diodes or a bridge rectifier configuration that employs four diodes. In both cases, both half of the AC waveform are utilized, producing a pulsating DC signal that is more efficient than the output from a half-wave rectifier. This leads to better performance in power supply circuit. And then we look at comparison of output waveform. Comparing the output waveform of half-wave and full-wave rectifier reveals significant difference. The half-wave rectifier yields a pulsating output corresponding to only one half of the AC cycle, which is characterized by a lower average voltage and higher ripple. In contrast, the full wave rectifier. In contrast, the full wave rectifier output feature a smoother and more consistent waveform, effectively doubling the frequency of the output voltage and significantly reducing the ripple, thereby improving the overall efficiency and performance of power supply circuit. Clipper circuits. Understanding the function and application of clipper circuit. First, clipper circuit function. Definition of clipper circuit. Clipper circuits are electronic devices that remove or clip portion of a waveform depending on predetermined voltage levels. They are usually employed to protect circuits from voltage spike or to shape a waveform in signal processing applications. Do you know how clipper circuit modified? Clipper circuit work by selectively eliminating either the positive or negative portion of an input signal. This process results in a modified output waveform that resembles the input waveform but with specific segments removed. The clipping threshold determines the voltage level at which clipping occurs, allowing for control over the shape and quantity of the output signal. Application example of clipper circuits. Clipper circuits are widely used in various applications, including signal processing in audio equipment to prevent distorting by clipping unwanted peaks in audio signal. They are also utilized in power supply system to protect sensitive components from overvoltage condition, ensuring instability and safety. Additionally, clipper circuits play a crucial role in communication system by shaping signals from effective transmission. Second, we're gonna be circuit setup and measurement. Circuit diagram of clipper circuit. The circuit diagram for a clipper circuit typically consists of diodes and resistors arranged to define the clipping threshold. For instance, a simple negative clipper uses a diode in series to allow only positive voltage level to pass, while negative voltage beyond a set level determined by the diode threshold. We're gonna we watch the diagram graph. A positive clipper, the sine wave, input sine wave is normal and output waveform is negative. But the negative clipper, input waveform is normal and output waveform is positive.
Then we look the waveform is half wave. Now for the full wave bridge rectifier, we put the jumper and then we connect in the transformer. We connect the load resistor in the series with the one diode. And then we connect the oscilloscope to the circuit. Now the waveform will be displayed.
Setup for measuring output. To measure the output of a clipper circuit, connect an oscilloscope across the output terminals after setting up the circuit. Ensure that the power supply is within the operating limits. Probe the output to capture the waveform and adjust the time base and sensitivity of the oscilloscope for clear visibility of the modified waveform. Observing waveform change. After establishing the measurement setup, observe the change in the waveform display on the oscilloscope. The wave will show the clip portion as flat peaks, illustrating how the clipper circuits alter the input signal. Note the specific of the clipping level and how they correlate with the design parameter of the circuit. Conclusion: clipper circuits are essential in various technology application, enabling precise control over signal shapes and protecting components from overvoltage condition. The ability to manipulate waveform proves invaluable in enhancing performance and maintaining reliability in electronic systems. That's about me to explain the diode and clipper circuits.